Good morning, everyone. My name is Parikshit Bhalke from class CS3, and I'll be explaining a crucial aspect of operating system, page replacement algorithms, focusing specially on FIFO and optimal algorithm. Let's explore how these help improve memory management and system performances. Slide 2, virtual memory and paging. Let's begin with the foundation, virtual memory. Virtual memory extends the address space beyond the actual RAM. It allows large programs to run even if physical memory is small. Like this is achieved through paging, which breaks memory into fixed size blocks called pages for virtual memory and frames for physical memory. The page table maps virtual pages to physical frames and tell the OS if a page is present in RAM or not. So why do we need page replacement? That's where page faults come in. The challenges or page faults. A page fault occurs when the CPU accesses a page not currently in the RAM. The OS must pause and load the page from secondary storage, but if RAM is already full, it must evict one of the pages. Like page fault, CPU requests a page not present in physical memory, OS action, operating system retrieves the required page from secondary storage, and that's the problem. If the RAM is full, an existing page must evict to make a space. And we have a solution. Page replacement algorithm decides when specific page to evict. So basically, yeah, page replacement algorithm decide which page should be removed. Now we gonna see the slide 4. Page replacement algorithm goals. There are specific goals that are related to page replacement algorithm. The main goal is of these algorithm is simple: minimize page faults first, and second, the maximize the hit rate pages found in memory. We evaluate algorithm using a reference string, a sequence memory of accesses. The fewer faults algorithm generates, the better it is. Now slide 5, FIFO. So we it's the full form and the short form of FIFO is first in first out. Let's begin the simplest algorithm with the simplest algorithm of FIFO. It evicts the page that has been in memory the longest, just like a queue. Think of it like a first come and first serve, like at a grocery store we go. And FIFO is easy to implement, but let's see how it performs with an example. So the example in this is in the slide 6. Yeah, so here's a walkthrough with three memory frames and this reference string: 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5, step by step. And first three numbers, 1, 2, 3, are all faults and fill up the frames. Then 4 replaces 1 and 1 replaces 2 and 2 replaces 3 and so on. So there are total 9 page faults. Important note: here's a very important thing, that FIFO suffers from the Belady anomaly. Sometimes increasing memory frames actually increase page faults. Yeah, and in slide 7 we're gonna see the pros and cons of FIFO. uh, Pros are, or advantages are, extremely simple to implement and understand, low overhead, minimal computation needed, or in other words, extremely simple and easy to implement with minimal computation. And cons are, it suffers from Belady's anomaly. From more frames equals to more faults, ignore pages usage frequency, evicts active pages, often performs worse than the other algorithms. Yeah, often performs worse than other algorithms means can evict actively pages usage. So clearly it's not always efficient. Yeah, and now, yeah, that's all. Now we're gonna move slide 8. So now let's explore the optimal algorithm. This is a theoretical best case scenario. It replaces the page that will not be used for longest time in the future. and requires full knowledge of future memory accesses, so it's not usable in the real time system, but it serves as a benchmark to evaluate others. Like concept, if it's a page not used for longest time in future, and purpose used as an ideal benchmark for evaluating other algorithms. And logic requires foreknowledge of entire reference string data, and mechanism look ahead to predict all future pages access patterns. So it's basically a benchmark to evaluate other things. Now we have an example of optimal algorithm as well. Let's use the reference string like 0, comma 2, comma 1, comma 6, comma 4, comma 0, comma 1, comma 0, comma 3, comma 1, comma 2, comma 1. So with three frames initially with fill with 0, comma 2, comma 1, then 6 replaces 1, used for later, 4 replaces 2, and so on. 0, comma 1, comma 2 stay longer if needed sooner. Final result, again there are 9 page faults, same as FIFO in the case, but often better. Again, this is the best case scenario, so yeah. So we have a difference between FIFO versus optimal. We are a difference between FIFO versus optimal, and there are four aspects: logic, complexity, practicality, and performance. Logic. First of all, we're going to talk about logic. FIFO awaits oldest page, while optimal awaits page used farthest in the future. And second, complexity. FIFO has very low complexity, whereas optimal very high, needs future info. And the practicality, FIFO is real world usable, and whereas optimal is only theoretical. And now last aspect, performance, often poor of FIFO, and optimal always best. So while optimal is perfect but it's not practical, FIFO is practical but not efficient. What do? We're gonna see in slide 11. Slide 11 is not here, but I have real world use. In this real world, we have approximation to optimal LRU, least recently used, price to predict the future by assuming past usage reflects future use. Clock algorithm adds efficiency by simulating LRU behavior. That's a strike, a balance between performance and feasibility. So my final thoughts are to conclude. Virtual memory always large processes to run on small RAM. Second, page replacement algorithms are vital for managing limited memory. Third, FIFO is easy but not smart. And optimal is ideal but impossible to implement. And real systems are use smarter approximated algorithm like LRU and clock. Yeah, that's for all. And that wraps up the discussion on page replacement strategies. So, thank you.